Hello, everyone. Welcome to Physics 205. So in this video, what I want to do is go over the diagnostic math assessment solutions. Okay, so in this first example, we're asked to solve the following equation algebraically for m. So we have F equals ma. We want to solve that equation for m, which means we want to isolate m right on one side of the equation. So because m is being multiplied by a on the right-hand side, if I want one m or m by itself, then I need to divide by a, right? So that'll cancel, but whatever I do to one side, I have to do to the other side. And then of course, it doesn't matter which way you write this because they're equal. So now I'm going to write that m on the left-hand side and write f over a on the right-hand side. So that's the answer. M is simply going to be f divided by a. Okay, question 2. Solve the following equation algebraically for a. All right, so we're given v sub f, right? V final equals v sub I plus a t. Okay, I want to solve this for a, which means, again, I want to isolate the a by itself. Well, first of all, I have this vi, right, added to the at term. I kind of want to isolate this term first. So I need to get rid of this vi. Well, to get rid of it, I can subtract it. But again, whatever I do to one side, I have to do the other side. So I'm going to subtract vi from both sides. If I write this again, now on the left-hand side, I have v final minus v initial. That's equal to a t. And then finally, to get a by itself, right, or 1a, since it's being multiplied by t, I need to divide by t. But again, whatever I do to one side, I have to do to the other side. So if I divide by t here, right, that gives me the 1. That cancels. I have 1a, but whatever I do to one side, I have to do to the other side. And again, now, since those things are equal, it doesn't matter which way I write them. I can write the right-hand side and the left-hand side and vice versa, right, because they're equal. So since we're solving for a, I'll write that on the left-hand side, and then right-hand side, I have v final minus v initial over t. And that would be the solution. Here, let me box in these solutions here. First page. Okay, so a equals v final minus v initial divided by t. So often you're going to be asked to manipulate equations, right, in this class. So we want to do some practice with that. Okay, the next question. Let's see. It says solve the following equation algebraically for vi. So now we need to isolate that v initial term. So first, right now, I want to isolate the vi squared term. Okay, so let me write this down again. So v final squared equals the initial squared plus 2a delta x. Okay, so to isolate the v initial squared term, I first need to remove that expression 2a delta x. Well, it's being added right-hand side, so why don't I just subtract it, right, to get rid of it. But whatever I do to one side, I have to balance it, or I have to do it to the other side. So now the left-hand side becomes v final squared minus 2a delta x equals, and then v initial squared. All right, and then I'm gonna rewrite this again, since they're equal. I'm gonna change this right away. I'm gonna write this as v initial squared equals v final squared minus 2a delta x. Right, so whatever I had on the right-hand side, I put on the left-hand side. And whatever I had on the left-hand side, I put on the right-hand side. Because they're equal, I can do that. Okay, now the question is, we're almost done, right? We have vi squared. We want vi. How do we get vi? Well, we can do that by taking the square root of both sides. So if I take the square root and then square root, now you have to be careful here. Whenever you take the square root, you have two possible solutions. It could be plus or minus. Now, often one of them will be the only one that makes sense, like physically will be the only one that makes sense, but mathematically you could have two solutions. So let me remind you how that works. So if I have like x squared is equal to k, and then I take the square root of both sides, then the answer, so square root of x squared is x, but then on the right-hand side, I have either plus or minus radical k. There's two possible solutions. Okay, so in this case, if I take the square root of vi squared, I get vi. That's what we're looking for. But I have two solutions. It could be either plus or minus, and then it's going to be the square root of v final squared minus 2a delta x. All that is underneath the radical, right? Underneath the square root side. So that would be my answer. And you would read that as vi is either positive square root of v final squared minus 2a delta x, or negative square root of v final squared minus 2a delta x. Okay, here's a system of linear equations. So it says, solve the following system of equations for a and t. And the hint is to use substitution. We could also use elimination. There's many ways of doing this. But substitution is probably the easiest. So to solve it using substitution, what you do is you first solve one of the equations for one of the variables. But that's already done for us, right? That first equation, it is already written, it's solved for t. And then once you have that, what you do is you take that expression for t and you go to the second equation, and wherever you have a t, you're going to plug in m1a. So that's where the substitution comes in. So I'm going to take this t, and where I have a t in the second equation, I'm going to plug it in. So, and don't forget the negative here, right? So I have negative, and now that t is really m1a plus m2g is equal to m2a. Okay, I want to solve this. Let's start first by solving it for a. Since we eliminated the t now, let's solve this for a. So I need to get the terms with the a, which stands for acceleration, together. So to do that, I'm going to bring this m1a to the right-hand side, right? So I have minus m1a, so to get rid of it on the left-hand side, I'm going to add m1a. And whatever I do to one side, I'm going to do to the other side. So now I have m2g is equal to, and I can write the right-hand side as m1a plus m2a. Okay, now I'm going to switch it just because I want to solve for a ultimately. I want it on the left-hand side. So I'm just going to put whatever I have on the right-hand side on the left-hand side. Again, because they're equal, I can do that. Because ultimately I want the a written on the left-hand side. Now the question is, how do I get a? It looks like it's trapped in both terms, right? It's common to both terms. So what you can do is you can factor it out. Since this a, right, is common to this term and this term, I can pull it out front. So if I do that, I have a, and I'm left with m1 plus m2, right, is equal to m2a, or sorry, m2g. So, and to check this, if you distribute this back in, a times m1 plus a times m2, you're going to get what you started with, right? So we went backwards. We factored out an a from both terms. Now notice on the left-hand side, the a is being multiplied by m1 plus m2, that sum. I want to get a by itself, or 1a. So I need to divide both sides by that sum. I'm going to write it one more time here. So to get a by itself, I need to divide by this sum, m1 plus m2, right? That'll cancel. But whatever I do to one side, I have to do to the other side. So I end up with a is equal to m2g over m1 plus m2. And that's my answer, right? At least that's a. Okay, if we want to go back and find t, what we could do is simply plug it back into that first equation, right? Because I have t equals m1a. And I know what a is, I just found a. So if I plug in a, this is going to be m2g over m1 plus m2. So this is simply going to be, if you multiply these, right, you can think of it as m1 over 1. This is going to be m1 m2g over m1 plus m2. So that's going to be my solution for t. All right, I found a. So all I'm doing is plugging in a, that expression for a, substituting in for here, and then t equals m1 times that. So that would be my answer. Okay, in this next question, it says solve the following equation for y given the values t equals 2, y naught equals 40, v naught y equals 0, and g equals 10. So really all we're doing is we're plugging in those values. So I'm going to write this down again. So where I have a y naught, I'm going to plug in a 40. Where I have a v naught y, I'll plug in a 0. Where I have a t, I'll plug in a 2. And then g, we're going to use 10. G is really this acceleration to gravity. Normally, and later on in the class, we'll use 9.8, but here we'll just simplify it to 10. And then t is 2 again. Okay, and then you're going to work this out, right, and get y, but just be careful, right? Order of operations is important. Really, you should do exponents first. So if I write this all out again, this is going to be 2 squared, which is 4. Then multiplication and division done left to right. So this one's easy, right? This is going to be 0. And then this will be minus 20. And then finally, we can do addition and subtraction left to right. So order of operations is important, right? And you may have learned this as PEMDAS, or please excuse my dear Aunt Sally, right? Parentheses are done first, then exponents, then multiplication, division left to right, and then addition, subtraction left to right. So finally, if I do addition, subtraction left to right, I have 40 minus 20, which is 20. And that would be my answer. Okay, solve the equation for t by either factoring or using quadratic formula. All right, so here's my equation. I have 10t minus 2t squared is equal to 0. All right, so if I want to solve this by factoring, it looks like a t is common to both terms, so I could pull out a t, and I'm left with 10 minus 2t is equal to 0. And now we have this situation, right, where we have like an expression, say a times another expression, b is equal to 0. So either a is equal to 0 or b is equal to 0. So in this case, either t, that first expression, is equal to 0, or 10 minus 2t is equal to 0. So the first case, it's already done for us, right? One solution is t equals 0. If t equals 0, then that whole expression is equal to 0. Like if you go back to the original equation, you plug in 0 here, you're going to get 0 minus 0 equals 0. So that's true. And then the other possibility is I need to solve this 10 minus 2t equals 0. So to do this, let me bring the t to the right-hand side just to make it positive. So I'll add 2t to both sides. You don't need to do that. You could bring the 10 over and then divide by -2 at the end, but I'll just make it positive. So 10 is equal to 2t. And then finally, to get t by itself, I'll divide both sides by 2. So it looks like t, I want to write on the left-hand side now, is equal to 5. So either t is 5 or t is 0, right? Both of those are solutions. Now, the other way you could have done this, you could have used the quadratic formula. So remember, if you have, let me remind you of that, if you have ax squared plus bx plus c is equal to 0, then the solution is going to be x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, right? That will always work if you have a quadratic equation. So the way I would do this, though, I would first write it in this form. So I would put the squared term first. So we had like minus 2t squared. plus 10t, right? And then plus 0, there's no constant, is equal to 0. So in our case, because we're using t's instead of x's, then it's going to be really t is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And what is a, b, and c? Well, a in this case is -2, right? It's the coefficient of the square term, of the t squared term, so -2. B is positive 10, and then the c is 0. There's no constant here. So b is equal to 10, and c is equal to 0, right? Whenever you use the quadratic formula, you have to write it in this form where you put everything on one side equals 0. And you should put the square term first, then the linear term, and then the constant. All right, so now that we know a, b, and c, we can just plug in, right? So we have t is equal to minus, b was 10, right? Plus or minus square root of 10 squared minus 4 times -2 times c was 0. All divided by 2 times a, which is -2. Okay, so I have -10 plus or minus. If you look inside this radical, right, this term right here is 0, so it's gone. And then 10 squared is 100, but square root of 100 is 10. It's going to be 10 divided by 2 times -2 is -4. So one solution is t is equal to -10 plus 10 divided by -4. But that's just 0, right? Because -10 plus 10 is 0 divided by -4. That's equal to 0. The other possibility is t is equal to -10 minus 10 over -4. Well, that's -20 divided by -4, which is +5. So again, we're going to get our same two solutions, t equals 0 and then t equals 5, right? Those are the two possibilities. Okay, convert the following number from decimal notation to scientific notation. So I have 237,000. So this is a large number, right? Remember, scientific notation, you want the number written as a number between 1 and, like, it should be really greater than or equal to 1 and then less than 10. So the way I say it is between 1 and like 9.9999999, right? You have to have a single digit and then the decimal point. Right now, the decimal point is at the end here. So I need to move it between the 2 and the 3, right? So I need to move it 1, 2, 3, 4, 5 places to the left. But when I do that, I correct it by multiplying by 10, and I have to add 5 to the exponent. So basically it's 10 to the 0 right now, it becomes 10 to the 5th. Okay. The one way that I think about this is if I have a positive exponent, that means it's a large number, right? Remember, it was 237,000 to begin with. So that should be correct. 2.37 times 10 to the 5th. Okay, now let's go the other way. So we're given a number, 9.37 times 10 to the -6, and I want to write it as a regular decimal number. Again, to me, the way I think about this is a -6 means, oh, it's a small number. So I want to move that decimal point. I want to move it, since it's a small number, I want to move it 6 places to the left. So this will become, move it 1, 2, so I need a 0, right? 3, 4, 5, 6. So it'll be 0 point, and then I'm going to have 5 zeros. 937. So that would be the answer. Okay, evaluate W when M is 10, VI, the initial is 2, and V final is 4. All right, so this is kind of like what we did earlier, right? We're just plugging in and being careful when we evaluate this. So we're given those particular values, we can just substitute them in. All right, so I have W equals 1/2, M is 10, V final is 2, nope, V final is 4, the square minus 1/2, 10, and then V initial is 2. Okay, so again, order of operations is important. So let me do the exponents first. So 4 squared is going to be 16. And then 2 squared is 4. Then multiplication and division left to right. So if I do 1/2 times 10 times 16, that's going to be what, 80? Minus, and then 1/2 times 10 times 4 is 20. And then finally, I can do the addition subtraction left to right. So there's subtraction in this case. So W is equal to 60. Right, so that would be my answer. This, by the way, is going to be related to work energy. We'll get into this near the end of the semester. So W is equal to 60. Okay, number 10. Indicate whether the slope of the line in the following graphs is positive, negative, 0, or undefined. Okay, so if I look at graph A here, see how the line is going, if I read from left to right, it's going upward. If you start at any point to get on another point in the line, I need to move up one. So like my rise is positive and my run to the right is also positive. Remember the slope, you can think of the slope as rise over run. So in this case, overrun. I'm starting at some point on the line. I'm moving up and then over. Okay, in this case, I'm moving up 2 over 2. So my slope is going to be a positive 1, but we just want to know what's positive or negative. So this one is definitely positive slope. So A is positive. What about B? Well, B, in this case, I'm moving up 0, right, and over whatever I want to move, 2, 1, whatever it is. So in this case, the slope is 0, and it makes sense, right? If you have remember, slope represents the steepness of the line. So if the line is horizontal, if it's flat, there's no steepness to it. So it has 0 slope. So that's 0. Now C, if I start somewhere on the line here, to get to another point on the line, say right there, I need to move down. So I have a negative rise and then a positive run. So negative to positive would be negative, right? So if you have a line that slopes downward as you read left to right, that's going to be a negative slope. And then finally, D is a tricky one. In this case, the rise is whatever value you want it to be, but the run is going to be 0, right? And since we can't divide by 0, this is undefined. So a vertical line, you can think of it as sort of like infinitely steep, but the best answer is it has an undefined slope. So this is really undefined. Okay, so horizontal line was 0, vertical is undefined. All right, question 13. Calculate the slope of the line on the following graph. Okay, so again, here we can use rise over run, right? So we know the slope is equal to rise over run, or you could write this as y2 minus y1 over x2 minus x1, right? It means the same. Or you could even write it as change in y, delta y over delta x. So if I label this if I relabel this x1, y1, and x2, y2, then I have m equals y2 minus y1 over x2 minus x1. So y2 would be 4 minus y1 is 2 over x2 is 4 minus x1, which is 1. And if I work this out, this is going to be 2 over 3. So it looks like the slope is 2/3. Okay. And again, that makes sense, right? Because if I think of it just in terms of rise over run, if I start here to get back on the line, I need to move up 2. So my rise is positive 2 and my run is positive 3. So 2 divided by 3. That's my slope. Okay, the next question, we want to solve for the unknown side C in the following right triangle. So first of all, it's a right triangle. And remember, if you know two of the lengths of the sides of a right triangle, you can always find the length of the third side by using Pythagorean theorem, right? So remember, the Pythagorean theorem is a squared plus b squared is equal to c squared. In this case, we know a and b. In fact, it doesn't matter which one you label a and b. I think I labeled the a, the 3 here, and then the b was this side. And then the c is always the hypotenuse, right? Which is the longest side or the side opposite the right angle. So now if I plug in, I have 3 squared plus 4 squared is equal to c squared. So this is going to be 9 plus 16 is equal to c squared. So this is 25 is equal to c squared. Now we rewrite it on the other side, so you have the variable on the left-hand side. And now to get c, I simply take the square root. Now normally, right, remember we have to account for the fact that it could be positive or negative. But because this is a length, it's actual physical length of the side of a triangle, then we're just going to take the positive solution. So we have plus square root of 25, which is 5. So that's the answer. So c is equal to 5. Okay, match the equation to the graph. So this first equation is x squared minus 3. So if you look at these graphs, right? First of all, this x squared minus 3, this should remind you that this is a quadratic equation, right? Because of the square term here. And quadratic equations have a parabola, right, as a graph. You could plug in a couple of points here. Like, in fact, if you look at this, if I plugged in 0 for x, right, 0 for x, then it should go through -3. So like my y-intercept is 0, -3. So it looks like this one must be that first possibility, right? So that's that. Second one, y equals -5. Well, if you have a constant equation, that's going to be a horizontal line, right? It's saying regardless of what the x variable is, the output is always -5. The y is -5. So if you look at this one, right? Regardless of what we have for x, if x is 0, y is -5. If x is -2, y is -5. If x is 3, y is -5. So the constant function, the horizontal line, is going to be that one. And then finally, -x plus 2, this is a linear function, right? In fact, you can think of it as y equals mx plus b, where the m is -1 and the intercept is 0, 2. So that's exactly this one. And of course, it's the only one left, so it must be that one. It's the linear function over here. So that's going to be that one. Okay, use trig functions to solve for x and y in the following right triangle. Okay, so we're given the angle here, 30 degrees. We're looking for x, we're looking for y. We know the hypotenuse, right, is 10. The long side is 10. So relative to this angle, what is the x? Well, it's adjacent, right? It's next to the angle, it's adjacent. So what trig function involves adjacent and a hypotenuse? That's cosine, right? SOHCAHTOA. So I know that cosine of 30 degrees must equal the length of the adjacent side divided by the hypotenuse. So now if I multiply both sides by 10, right, I can solve for x. This will cancel. So x here is going to be 10 times cosine of 30. And then it depends on how you want to solve this. If you want it exact, remember cosine of 30 is square root of 3 over 2. So you can write this as 10 times square root of 3 over 2. So that would give you, I guess it'd be 5 times square root of 3. Or a better way is just approximate it as a decimal value. So if you plug that into your calculator, 10 times cosine of 30, just make sure your calculator is in degrees. If you do that, you're going to get x is around 8.66. Okay, so that's the x value. Now y, if you look at this picture again, the y is opposite of the angle here. and we know hypotenuse. So what trig function involves opposite in a hypotenuse? That's going to be sine, right? So sine of 30 degrees equals opposite y over hypotenuse. And then again, if I multiply both sides by 10, I can solve it for y. So the 10s cancel. I get y is equal to 10 times sine of 30. It turns out sine of 30 is exactly a half. So that's going to give y is equal to 5, right? And you'll get that too if you plug into your calculator. So y is 5 and x is 8.66, right? So now we know all the sides of that triangle. Okay, and then finally, this last question, it says, given the following linear equation, find the slope and the y-intercept. Okay, so it's a linear equation, right? Because both of the variables are raised to the 1 power here. And if we want to find the slope and y-intercept, we really want to put it in the form y equals mx plus b. Because then we can just pick out the slope. The m here is the slope. And then usually people say the b is the y-intercept, but really the y-intercept is an ordered pair. It's 0, b, right? It's a point, 0, b. Okay. So how do I do this then? If I want to put it in that form, I need to solve this equation for y, right? So if let me write it out here. You could bring the y over to the right now to make it positive, but if not, here, I'll do it the other way. Let's just get rid of that 4x. So I'll subtract 4x first. So bring it to the right-hand side by subtracting it. So now I have negative 3y is equal to negative 4x plus 7. And then to get y, 1y by itself, since it's being multiplied by negative 3, I need to divide by negative 3. But whatever I do to one side, I do to the other side. Right, so this will cancel. I'm going to get y equals, and I want to put each term over that negative 3, and then we'll simplify. So it's negative 4x divided by negative 3 plus 7 divided by negative 3. Now, of course, a negative divided by negative is positive, so I can just write this as y equals 4/3 x. And then positive by negative is negative, so I can write this as minus 7/3. So this tells us that the slope is 4/3, right? Just pick it out. It's the coefficient of the x term. So just pick it out. So we have the slope. And then the b here, the b is just this term, negative 7/3. And remember, it's like plus b, so you have to take the negative sign here. So negative 7/3. But if you want it as an ordered pair, the y-intercept is really going to be 0, negative 7/3. Like that's where it would intercept the y-axis, right? If you were to plot this on a graph. So 0, negative 7/3. Okay, so hopefully that was helpful, and we will definitely use these math skills throughout this class. Great, thanks.